Welcome to Unit 2, Lesson 5. Topic is average cost curves. Last lesson we were introduced to the marginal cost curve, which is an important concept for a firm. And these graphs of the average cost for firms are going to be pretty useful too once we start to analyze firm behavior. So that's what we're going to be looking at today. A lot of this just involves some pretty simple calculations, and we'll focus more on the relationships between these curves, the typical shapes that they have, and why that is. So we're going to pick up an example that was used in the last lesson. Last lesson, when we looked at the marginal cost curve, we saw this data on boots, production of boots with a fixed cost of our fixed inputs of $108, and then variable costs that increased as you increase production as a result of diminishing marginal productivity. So just remember all that. Well, we can break those costs down further into the fixed costs and the variable costs separately, and then taking the averages of those plus the total cost. So remember that the total cost is always equal to the fixed cost plus the variable cost. And the concept of average total cost, average fixed cost, and average variable cost is simply just dividing all of these things by the quantity of output. And the names for those are ATC for average total cost, average fixed cost, and average variable cost. And I just did that quick little setup there to show also that just as it's true, the total cost equals fixed cost plus variable cost. Also, average total cost is equal to the sum of average fixed cost plus average variable cost. It works the same way. So Q is, again, quantity of output. And so all we're doing is we're dividing the total cost, the fixed cost, and the variable cost at any level of output by that amount of output to get the average. It's very simple. So I won't do all these calculations and bore you with that, but just to make sure that you see it done. So fixed cost, for average fixed costs, to fill in the first of these here, we would take the fixed cost of 108 divided by 3, which is 36. And that is our average fixed cost. For our average variable cost, we take our variable cost, also happens to be 108. Those aren't always the same, but they are at this level of output. And 36 there. Generally drop the cents if you're dealing with whole dollars, although they're not all whole dollars on this table. And then the average total cost is just the sum of 108 plus 108, which is 216. And the average, again dividing 216 by 3, gives us $72. So we could do that, follow those calculations to fill in the rest of this table, and I'd even recommend that you pause and do so just as a practice, but it's all very simple calculations. It's a little bit tedious, but we'll do several of these until the concept is kind of drilled into your head. So there's the calculations of them. When we graph them, there's a few things that we can notice. Let's start with the average total cost curve. So our average total costs, if we were to find all these up here and then graph them, it would look like this. For the first 3 units, it starts with average total cost decreasing. With average total cost, this is not necessarily an issue of specialization. Remember, with marginal cost, we said sometimes marginal cost is U-shaped because it starts off with specialization decreasing cost per unit and then diminishing returns increasing cost per unit. Well, with average total cost, it's a little bit different because in this example here, we actually have diminishing returns from the beginning. If you remember the marginal cost from this graph, it was immediately increasing, which meant that we had diminishing returns from the beginning. But average total cost is still U-shaped. Reason for that is when you have a fixed cost that's the same all the way through your output, then what you're doing, your fixed cost is going to be relatively high compared to your variable cost for those first few units of output. Look how much bigger the fixed cost is than the variable cost for the first pair of boots and for the second pair of boots. It's not until the third pair of boots that the variable cost catches up to the fixed cost. So basically what we're doing here, we can call this spreading out our fixed costs. And that's why we're decreasing the total cost per unit on average at the beginning as we increase output at those low levels. Then eventually, once you've spread that fixed cost out a little bit, you reach this minimum cost output of 3, it's the lowest average total cost, and then basically diminishing returns kicks in and takes over that spreading effect. And so average total cost ends up increasing just like marginal cost always does. So average total cost is always going to be U-shaped because of first spreading out your fixed costs and then eventually with diminishing returns kicking in. Okay, if we graph all the rest of these, they look like this. This marginal cost actually comes from when we did this in the last lesson. And then we've put on top of it the average total cost, average variable cost, and average fixed cost curves that go along with the data in the table. So notice a few things. The average total cost, we've already said, is U-shaped. The average variable cost is going to have the same shape, not the same slope, but the same shape as the marginal cost curve. If marginal cost is U-shaped, then average variable cost will also be U-shaped. In this case, marginal cost is a straight increasing line. That's because we have diminishing returns from the beginning. And the diminishing returns come from the variable costs, come from the variable inputs like the workers, not from the fixed costs. Then with AFC, average fixed cost, notice that this is basically getting closer and closer to 0. It's approaching 0. It's always going to be the case when you're taking a single number, 108 in this case, and dividing it by a bigger and bigger number, a larger and larger quantity as you go up. So average fixed cost is getting smaller and smaller as we increase output. Notice also that because ATC is the sum of ABC plus AFC, that the distance between, I'm going to shade this in and then I'll erase it, the distance between ATC and AVC is equal to AFC. The distance between ATC and AVC is equal to AFC. So since AFC is approaching 0, ATC and AVC are always kind of drawing closer together. They're never going to intersect, but any ATC and AVC curve you see should be kind of getting closer together because AFC is always falling. Those are kind of the standard shapes for average total cost, average variable cost, and average fixed cost right there. Okay, so there's some important things about what you'll find with those cost curves. Eventually we'll just kind of sketch them like I did in red over here all the time. But at first, first time we introduce this, then we do a bunch of calculations with them, kind of plot them a little bit, just to get real familiar with their shapes. Okay, there's also significance to where the marginal cost curve crosses through both the average total cost curve and the average variable cost curve. And here it is written out just in bullets here. The marginal cost curve intersects both the ATC and, it's not shown in this graph, but the AVC also at their minimum points. Remember back a couple slides ago, I mentioned this minimum average total cost point. If we had a marginal cost curve going through here, it would intersect right there. This is a mathematical certainty because of the way that marginal cost is related to average total costs and average variable costs. The marginal cost is the cost of an additional unit of output. So if your marginal cost is below your average total cost, then your average total cost must be falling. Easiest and best example for this, I think, say that your grade in this class is an 85 currently, your total average, going into the next test. And on that test, what's going to happen to your total average grade if you get lower than that, say an 80? Well, you can recognize instantly that your, back to here, it's going to pull that down, say that that goes down to an 83. So same thing's happening here. So, call this the 80, and this, I'm sorry, this the 85, and this the 80. You know, if your marginal, if your next grade is lower than your current average, it's going to pull your average down some. Whereas if your next test is higher than your average, let's go back to our average of 85, your next test is a 90, it's going to pull your grade up, and that could be shown by this part over here. Now the marginal here is higher than the average, so whenever the cost of the next unit is higher than the average, then it's pulling that average up. So if marginal cost is below average total cost, it must be pulling average total cost down. Marginal cost is above average total cost, it must be pulling average total cost up. That means at that intersection point where marginal cost intersects average cost, that is the minimum ATC, minimum average total cost point. And that is actually really useful in later chapters to know where the minimum ATC is and how you can find it with the marginal cost curve. Same exact thing is going to be true with AVC, and we'll draw it again and repeat the whole thing, but the marginal cost cuts through both of those, the ATC and the AVC, at their minimum points. And this last slide I'll use for this is kind of the most common standard versions that you'll see of these curves of marginal cost, average total cost, and average variable cost. Remember, we've gone through this before, that with a U-shaped marginal cost curve, it's because specialization is decreasing marginal cost until this point, at which point diminishing returns kicks in. And then here we have the marginal cost cutting through the average variable cost and the average total cost at their minimum points. So we would say that this cost here is the minimum average variable cost, and then this cost here is the minimum average total cost. We can tell that just from those graphs. And we also know that this quantity here is the quantity at which average variable cost is minimized, and this quantity, called Q2, is the quantity at which average total cost is minimized. Okay, those are the relationships to know. The problems we're going to do in the book deal with this both in terms of the numbers, the calculations, and the conceptual level, the different shapes and relationships. Those are the things you need to know about those curves. We need to have these real firm before we move on in the next chapter to really use these to talk about what a firm is going to choose to do in terms of what quantity they produce related to the cost and the revenues that they'll get from it. That's it. See you in class.